So on page 242, you needed to create and recopy the parallelogram shown in the question, and then using grid paper try and calculate the area that the parallelogram covers in squared centimeter grid paper. Well, looking at the diagram that you see here, I'd like to go over the model for how you need to create or calculate the area underneath the parallelogram, one way that you could do it. So the instructions state that you should take your protractor and identify a perpendicular off of the base line of your parallelogram. Now you can rotate your parallelogram to make it look this way. You want to have a nice flat bottom, nice flat top, and don't forget there's two pairs of parallel lines. Does it matter which direction it's facing? No. You could have this on the bottom, this would be the top. It really doesn't make a difference. You're going to follow the same instructions anyway. So you could take your protractor and then position the bottom of the protractor along the bottom line of your parallelogram. And the instruction is to make a perpendicular. Well, if you were to position your protractor here, the perpendicular line off of the base line from your parallelogram would go here, and it doesn't help us connect the baseline of our protractor, or the baseline of our parallelogram, to the top line of a parallelogram. Why do we want to connect them? We're trying to create a line to represent the height of the parallelogram. So if we were to connect the perpendicular line here, well, it's not really representative of the actual parallelogram. Ideally, you want to have the line inside of it. So the furthest left that you would want to go is about here. And to draw the perpendicular, again, you need your lower arm along the baseline of the parallelogram, and then the other arm goes 90 degrees from the baseline, which would be here. So once you've got that marked out with your protractor, use your pencil, place a dot on your paper, move your protractor out of the way, and then draw a nice straight line. Now I think I've got a line here already, so I'm just going to bring it into the picture. There it is. Just to speed things up a little bit. So that's the line that represents the perpendicular off of the base of the parallelogram, connecting it to the top of the parallelogram. This red line represents the height of my parallelogram. So if that's the height, now the question is, how can I take my parallelogram and take what I've just found out about the perpendicular height of the parallelogram to help me find the area of it? Well, you can use a process called decomposition. So we're going to decompose the protractor, and when we decompose the protractor, we're going to decompose the parallelogram, and when we decompose the parallelogram, we're going to try and recompose it into a shape that we do know how to find its area. And what shape are we looking at? Well, let's see, maybe a rectangle? It's something that you're a little bit more familiar with. So I'm just going to shrink it down, and I'm going to do some manipulation now. And I'm going to enter that word just so you don't forget. Decomposition. If you're looking for the spelling too, you can find it in the word list on the class website. Recomposition. Decomposition is essentially to break down. Recomposition is to put together, or to reconnect, or to recreate. So essentially what we're doing here is we're going to, again, use our perpendicular to identify the section that we've created in our parallelogram, which is a triangle. So what I've done is I've taken that section and shown it here. So here's the triangle. Simple? So that creates a triangle when we drop our perpendicular right there. Now watch what I can do with the triangle. I'd like you to imagine that we take this section, we decompose our parallelogram, move that triangular section here. So if I move it there, that means this isn't here and this isn't here, because those pieces have been moved over to this side. So now what shape do we have left? What do you see? What if we taken our parallelogram, from and changed it into. Our parallelogram has now become a rectangle. And with this rectangle, what can we do? Well, you're pros at finding areas of squares and rectangles. I know you are. So what we can do is we can identify the number of square units inside of this rectangle by simply counting them. Or we could build an array. And if you were to build an array, you would count the number of square units across and multiply that by the number of square units down. 3 times 2 would be the same as counting the number of square units inside. Now the hard part is, how do you find out the area of the parallelogram? Is it related to the area of this rectangle that we've just built? Talk about that with the people you're sitting with. Can you decompose and recompose all of the parallelograms that you've been looking at?